Okay, so in the last video we worked out that the area that we needed for an 8 meter per second terminal velocity was 0.10949 0.10949 meters squared. Okay, that's the area we need. So we're now going to look at using a flat hemispherical, not a flat hemispherical, a flat hexagonal. Hexagon is like this, a flat hexagonal shape for our parachute. So what we need to figure out now is what would be the diameter, that's meant to be a straight line, what would be the diameter that we would need in order to give us an area of 0.10949. Okay, so basically what we do is we'll have a look at one of the triangles. We should all agree that there are 6 equal area triangles. So we're going to look at getting the area of one. Okay, so if we call this length R and this length R, D being 2R, we call this angle theta. We want the area of just this one here, and then hopefully you would agree that the total area is then 6 times the area of this triangle. As a matter of fact, we could do a generalized version of that where it can be an n-sided polygon. Okay, and then the area of the total would be the area of one triangle multiplied by n. So let's look at the area of one triangle. So we have a triangle here, R, theta. And hopefully everybody has done from trigonometry at this stage. The area of a triangle is a half the length of one side times the length of another side times the sine of the angle between them. Okay, so the area of just this one is a half r squared sine theta. Okay, now theta, if we look, if we have n triangles, that means 360 degrees divided by n will give you theta. And in this case, it would be 360 divided by 6. So we can replace the theta with 360 divided by n. Okay? Now that means that the total area total for the flat polygon is n multiplied by a half r squared sine 360 over n. Okay, that gives us the area that we require. Okay, now from that, d, the diameter, is 2r. Okay, so r would be equal to d divided by 2, the diameter divided by 2. So if we replace that with d, that will give us n over 2 d squared over 4, because if r is equal to d over 2, r squared will be d by d, which is d squared, over 2 by 2, which is 4. So sine 360 over n. That will give you n d squared over 8 times the sine of 360 over n, and that's equal to the area. So from that, we're going to derive an expression just for d squared, just by manipulating that data. So we'll rub this bit out, and if we have a look here, that means if we multiply across by 8, remember this is just the sine of 360 by 8, we have 8a is equal to n d squared sine 360 over n. D squared will then be 8a over n sine 360 over n. And d obviously then will be the square root of that. Okay, so we can now put in our value for a. Okay, and we can put it into that formula. So D will be equal to the square root of 8 times the 0.10949 meters squared over, now in our case, if we're going to talk about a hexagon, that's going to be 6, n is 6, sine 60. Because 360 divided by 6 is 60. Okay? And I believe, but I did it quickly, so you guys can verify that that gives you a diameter of 0.41 meters or 41 centimeters. So that should be an easy enough parachute to cut out. And that is the parachute that was used for CANSAT 2016. Okay? I will do another video now just describing a bit more about the drag coefficient.